Welcome to the video tutorial. This is Unit 7, pages 5 and 6. It's got a tiny little title up there. We're doing empirical and molecular formulas today. So this table is fantastic because not only does it go over our new stuff, it's reminding you stuff you should know from Unit 6, naming and formula writing. So in this first column we have the molecular formulas. Molecular formulas are not reduced, which would be like this one, H2O2, unreduced, and we leave them unreduced when they're covalent. So when they're both nonmetals, then we leave them unreduced. When you have something like this up top, lead to sulfate 4, we tend to reduce ionic compounds. So in this table you're doing both. You're doing molecular and empirical. Sometimes they're the same, sometimes they're not. But just be aware that covalent compounds should be left as molecular, while ionic compounds should be not. They should not be. They should be reduced. So I've been having my students just kind of cross out any ionic molecular formulas like that so I can still read it, but just so that you know that that's not appropriate. We reduce ionic formulas. Okay. So I already started this one for you. Tin 2 oxide. And this is ionic because tin is a metal. So we know that's ionic, which means SN2O2 is the molecular formula, but that is not an appropriate formula for ionic. We usually reduce that and we make it just SNO, tin 2 oxide. So this would be the correct answer, but this is technically the molecular formula. Coming down here, iron 3 phosphate, I wrote that formula, Fe3PO43. You can check my work over here. This is ionic because iron is a metal, and in which case this is an inappropriate molecular formulas. We usually reduce it. Because these are both 3s, we would take them off, FePO4, just like that. Right. So this is the molecular formula, this is the empirical formula, but remember for ionics we always give this as our final answer. For covalents we leave this as our final answer. Looking down at this one, you can see that the molecular and the empirical formulas are the same, and that's fine. Sometimes they are. This is silver and phosphorus. Silver is a metal, so that's ionic, and silver is the 1 in 1b that is always +1. So silver does not get a Roman numeral when we name it. We just call it silver phosphide. Okay. Let's look down here. Let's skip where it's dinitrogen tetroxide. And technically that should just be tetroxide, not with the A. N2O4. Dinitrogen is 2 nitrogens, tetra is 4, so 4 oxygens. This is the appropriate answer because that is a covalent molecule. They are both nonmetals. But if we were to ask you for the empirical formula, you would reduce. So remember that 2 over 4, those subscripts, the fraction 2/4 can be reduced to 1/2. So anytime your subscripts are both even, you divide them by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So we can reduce that to a 1 and a 2, and then it's just invisible 1 and 2. We did a lot of these in class, so I'm going to have a skip down here. We're going to start with octane. Octane is the official name for what we would call octacarbon and then H18. So the name octane isn't something you would have to know. This is a covalent compound because carbon and hydrogen are both nonmetals, which means this is the appropriate answer for covalence, but we can also reduce it. Those are both even numbers, so I can divide them by 2. So 8 divided by 2 is 4. I can say C4. And 18 divided by 2 would be 9. So I can reduce this to the empirical formula, C4H9. Hexane, C6H12. Again, carbon and hydrogen, both nonmetals. That's covalent, which means this is an appropriate molecular formula. But we can reduce this. They're both even numbers, so we can divide them by 2. But they are also both divisible by 3. So I can go 6 divided by 3, and I can go 12 divided by 3. So 6 divided by 3, oh, excuse me, I just wrote down the number 6. I can't talk and write at the same time always. So 6 divided by 3 is 2. 12 divided by 3 is 4. Okay, but look, it's still a 2 and a 4. Alright, so I can divide it by 2 again. 2 divided by 2 is 1. And 4 divided by 2 is 2. So you can kind of reduce and keep checking, but look I can go 6 divided by 6 is 1, and 12 divided by 6 is 2. So just kind of guess and check, keep working. Magnesium carbonates, if we're going to write that one, and I'm going to do it over here where I have room. Magnesium is Mg. Carbonate right here is CO3, and that makes a -2 charge according to this polyatomic list. Magnesium over here in 2A, A always makes a 2 charge. So I'm going to call that +2. And then I crisscross 2 and 2. Now I write that down as my unreduced formula, Mg2, CO3, 2. Okay, this is ionic because magnesium is a metal, which means this would not be an appropriate name for it, because I would reduce those 2's off if I was going to give this answer on a test and just say Mg. CO3. That's the reduced answer. Okay. Down here it says write the empirical formula for these mystery compounds. Now in class we talked about the empires and like Star Wars and the Empire, Darth Vader. Okay, things like the Death Star and stuff were very utilitarian, very white walls and white surface and black whatnot, but very simple. Okay, very bare. There was no decoration, no paintings, no color. So very simple. So empirical formulas are simple. They're reduced. So in this case, 4 over 20. Those are both even numbers, so I can divide them by 2 and get 2 over 10. Well, those are both still even numbers, so I can divide them by 2 and get 1 over 5. Okay? Or you could have just done divided by 4. 4 divided by 4 is 1. 20 divided by 4 is 5, but I can't reduce this anymore. So there is my empirical or reduced ratio. So that would be x instead of 4, 1, and 1's are invisible, so we wouldn't put it there. And then z instead of 20 becomes 5. X invisible 1, z5. Looking here at 9 over 27, we can make those subscripts a ratio. Those are both divisible by 3. 9 divided by 3 is 3. 27 divided by 3 is 9. Okay, well we can still divide that by 3 more, right? 3 divided by 3 is 1. 9 divided by 3 is 3. Again, that's kind of how my brain does it, is dividing by 3's. If you knew that you could divide 9 by 9 is 1 and 27 by 9 is 3, that's fine too. So I end up with y1, which is invisible, and x3. And then down here, 6 and 22. 6 over 22. Okay, 6, they're both even. So 6 divided by 2 is 3. 22 divided by 2 is 11. And I can't divide those by 2's. I can't divide them by 3's, so we're done. So that would be Q instead of 6, we'd go 3. X instead of 22, we'd say 11. That's how you go from these pretend moleculars to these pretend simplified empiricals. This is the big focus for today, that you're able to do this. There is also this page on the back, which is a little bit more of an extension, but we do give you the directions right at the top. So we took notes on these as well. So in these questions, and I'm just going to show you one real quick, they tell you that the molecular formula is blank, and the molar mass of it is this, and they're asking you, what would the molecular formula be then? So if this is the empirical formula, this is the simplified formula, what would the unsimplified formula be? So the steps, it tells you to first find the molar mass of the given empirical formula, and then you divide the given mass by your calculated mass, and you multiply them. Okay, so look at these steps. I can't have them on screen when I do this, but for number 4, and I'm just going to pull this one here so you can't see the rest yet. It says, what is the molecular formula? So they're wanting a molecular formula as their answer. I'm going to circle that as my unknown. If the empirical formula is CH2O, and it has a formula mass of 120 grams. So I did 1 carbon plus 2 times hydrogen plus 1 oxygen, and I got that the molar mass of this empirical formula would be 44.264. So again, molar mass, that's step 1. Calculate the molar mass of the given empirical formula. Okay. Then it says divide the molar mass given by the empirical mass calculated. So I'm going to take my given mass of 120. Okay. 120 is the given, divided by 44.264. That gives me 2.7, so it's just about 3. Okay. So that means each CH2O weighs about 44, but total I have 120, which is about 3 times as many. So I'm going to, on step 3, multiply the empirical formula, this one right here, by the number I just found. So C1, that's an invisible 1. C1 times 3 would be 3. H2 times 3 would be H6. And O1 times 3 would be O3. Okay? Which just means my molecular formula is 3 times bigger than this empirical formula. Okay, that's what I'm going to do here on number 5 as well. The empirical formula is C2HCl. So the first thing I do is I found the molar mass already. 2 times carbon equals this, 1 hydrogen and 1 chlorine. And I added up all of those masses and I got that the molar mass of the empirical formula is this. So I'm going to take my given molar mass of 181 and I'll put this where we can see it. Where can we see it? We'll put it right there. There we can see it. Just about. 181.5 divided by my calculated molar mass of 60.483. And that gives me a factor of 3. Okay? Which means my molecular formula is 3 times bigger than this empirical formula. So 3 times 2 carbons will be C6. 3 times 1 hydrogen will be H3. 3 times 1 chlorine will be Cl3. So this is the reduced empirical. Here is the unreduced molecular. Okay, and then our last one down here. It's NO2, nitrogen dioxide. So 1 nitrogen plus 2 times oxygen. Here's the molar mass of NO2. If this is how much is in the molecular formula, okay, 91.08 divided by my calculated molar mass, which is 46.005, that's about 1.97. That's about a factor of 2. Okay? So my molecular formula was 2 times heavier than my empirical formula. So I need to go 2 times my empirical formula. 1 nitrogen times 2 is 2. 2 oxygens times 2 is 4. There's my unreduced molecular formula. Okay? So that's what y'all should have done for 1, 2, and 3. You are going to have to memorize these 3 steps. There will be questions like this on your exam, but we won't give you the steps. Okay? Great job today, y'all.